Topic 10, Part 2. In Part 2, we're going to move on from using the first derivative test. We're going to look and see if we've got one test that we can use that will kind of encapsulate the first derivative test, but using one calculation. Probably you will find the second derivative test a better test to use. There's fewer calculations to do. You're not likely to be looking at the left-hand side when you really need to be looking at the right-hand side, and so on. You most certainly do not need to do both tests, as they tell you the same thing. What we're looking at here is that if we have a maximum point, then the slope is becoming more negative. It starts off positive, it's 0, and it becomes more negative. So the slope is becoming more negative. Now, if you think the derivative tells us how y changes, and the second derivative tells us how the derivative changes, or in other words, it tells us how the slope changes, then we can use the second derivative to describe what we've just got. So in this case, as the slope becomes more negative, what we really want to say is that the second derivative is negative. And if we've got a situation where we first up find where the first derivative is 0, and then when the second derivative is negative, then we have a max. If we have this shape, the slope is becoming more positive. So in this case, the second derivative, for the same reasons as the first one, the second derivative indicates that the slope is becoming more positive. And if the slope is becoming more positive, then we have a minimum. If we actually have no change in the slope, if it's going from positive to positive, or if it's going negative to negative, we don't actually have a turning point, then we say that the slope is not changing and that we have a point of inflection there. So it's not part of the course, but it is useful to know what a point of inflection is. So if we've got a maximum, the second derivative is negative. If we have a minimum, the second derivative is positive. To locate the turning points, first up we find the derivative. And the derivative of this is x squared plus x minus 12. And that's got to equal 0 for max or min. And we find that from that x is equal to 4, or x is equal to x is equal to negative 4, or x is equal to 3. And if x is equal to 4, negative 4, y is equal to 119 over 3, crazy answer. And if x is equal to 3, y is equal to negative 35 over 2. We also need to know what the second derivative is. Oops, back to front. Stupid pen. Second derivative equals 2x plus 1. Okay, so we need to look at the second derivative when x is negative 4, so call that point 1, call that point 2. So at the point 1, where x is equal to negative 4, the second derivative is negative, so there's a maximum there. Which we kind of knew by looking at the y values that is indeed the bigger of the two. And then if we look at point 2 and we apply x equals 3 into the second derivative, so then we find that the second derivative is positive. And where the second derivative is positive, we have a minimum point. So we've got a minimum at 3 negative 35 over 2. Now, the graph's a bit small, but you can kind of see that there's a maximum on the left where x is negative 4. And that maximum value, this is the bit that you're actually looking for. The maximum value is 119 over 3. Then if you look... Okay, similarly here we're going to solve where y dash equals 0. And if we do that, we find that x is equal to 3, or x is equal to negative 2, and the corresponding y values are negative 11 and 5/6 and 9. Now we can see from looking at that 9 is the maximum value of y. So we suspect that x equals negative 2, y equals 9 is the maximum, and we suspect that x equals 3, y equals negative 11 and 5/6 is the minimum. But we need to check. That means we need to find the second derivative. And the second derivative is 2x. It's 2x minus 1. So we need to substitute x equals 3 into that. So let's say at x equals 3. Then the second derivative is going to be positive. So that means we've got a minimum at that point, and that's what we thought. And then we need to look when x is negative 2. And remember, we're looking at the second derivative. So we're going to put negative 2 into 2x minus 1, and we find that the second derivative is negative there, which tells us we've got a maximum at that point. Which is what we thought anyway. We can then put that information onto a graph. We can show that there is a maximum at negative 2 of 9 and a minimum of negative 11 and 5/6 when x is equal to 3. There are two ways of doing this. You can actually do it without using calculus, and it's probably quicker to do so. Remember from topic 6, we could rewrite this using r is equal to the square root of a squared plus b squared, and that alpha was equal to the inverse tan of b over a. So using that, we can find that y is equal to 5 sine x minus 0.64. Now, what we need to be able to look at there and say, okay, we know what that shape is. We know the maximum height. We know that the height, or the amplitude, is 5. So the max value is 5. But what we do need to know is we need to know the x values at which that occurs, or the x value, if you like, when that occurs. So we need to solve 5 is equal to 5 and working that through, dividing both sides by 5, finding the inverse sign, so x minus 0.64 is equal to sine inverse of 1, and then x is equal to sine inverse of 1 plus 0.64, and we get x equals 2.214, remembering your calculators in radians. Now if you think about this, this is just an ordinary sine curve. Omega is 1, so it's the sort of sine curve that has a period of 2 pi. So the difference between the maximum and the minimum is pi. So we're going to add pi to that, and we get 5.356. So we know that this one then must be the max, and this one must be the min, and that's perfectly acceptable working for the exam. You don't have to use calculus. If you want to use calculus, you need to find the derivative, make the derivative equal to 0, solve it for x, you get 2 answers, and you end up with the same 2 answers as you've got there. Now the information that we've just found, we can put on a graph that the maximum point is where x is at 2.214 and the minimum point is at 5.356. Now we would need to find this point here, -3, that we find where x is equal to 0, and putting that into the equation and finding the value of y.